Hi, welcome to the Shiko Math Lab. And this is our AP Calculus lecture series. And this is our lecture number 4. In this lecture, we're going to talk about continuity. Before we start, let's give a very brief review what we learned so far, right? So we spent the first 3 lectures to talk about the limits. You will wonder why we work on limits so much. Okay, so before we get into our calculus, we call this the derivative part, differentiability part, and we have 3 levels. All right, so the level number 1, this is I call this the lowest level. So in this level, we talk about the limit exists. Okay, so in this level, we say, how do we define the limit exists? So we say, okay, the limit x approaching to a from the left-hand side, f of x, going to be equal to the limit x approaching to a from the right-hand side, f of x. And if they're all equal to L, then we will say the limit x approaching to a, f of x equal to L exists. Okay, so this is our first level, is we talk about the limit. Then the next level is going to, before we reach the differentiability will be our highest level. So the next level is the continuity. And this is what is this lecture we're going to talk about the continuity. So what is the continuities here, right? So why we will say this is my level 2 here, okay? So let's take a look at what is our definition. So we said what the definition of a continuity means. How do I define the f of x is continuous at x equal to a. So let's see here. So the first conditions we said, in order to be continuous, so we said that when the limit x approaching to a, f of x, this limit has to exist, right? So this is our condition number 1. And so let's put it this, this is number 1 has to exist. Then we say the function value. What is the function value? That means you replaced x with a. So we say f of a has to exist. I say this is a condition number 2 here. Then the last condition, we say the limit x approaching to a, f of x has to equal to my function value, f of a. So this is, I said, this is number 3 here, right? So this is number 3. So as you can see, the reason why this is level 2, because I add this condition, I add this condition. When we talk about the limit exists, I do not have this condition. I just say for the level 1s, here, limit exists. As long as right limit equal to left limit, that is all I care. But for here, we have, the add 2. That's why we say we jump up 1 level, become level 2 here. All right, let's take a look. What I mean here, let's take a look at our several discontinuity situations here. All right. So obviously, okay, so obviously if you have some function look like this. All right, so this is the, so A, obviously this function is not, continuous. So which condition this function violate? So we know this condition here, right? So when the limit, when approaching to left, going to approaching to this value, approaching to right, going to approach to this value. So I know for this function, limit exists. So which one I'm violate? I'm violate is a condition number 2 here. This is valid. Right? Because the function value f of a not exist. That's why this is discontinuous. Okay, so let's take a look at this situation here. So if I have a function, okay, let's say here, if I have a function go like this way, I have a function go like this way here. All right, so this is my A. So which condition, 1, 2, 3, which condition it violate? Let's take a look. If I approaching to A from the left-hand side, I'm approaching to this value, but I'm approaching to A from the right-hand side, I'm approaching to this value. So which condition I'm not satisfied? Condition number 1, not satisfied. Right? Because I violated condition number 1. So what is the condition number 1 here? The limit x approaching to f of x not exist. All right, so now let's take a look at another example here. So here, let's see here, if I have it here, here. So if this is my f of x, so let's take a look. All right, so if I have limit here approaching to A from left-hand side is approaching to here. Limit approaching to A from right-hand side is approaching to here. So limit exists. That's good. And then this here, this is my function value, right? This is my function value, f of A. So both 1 and 2 exist. But unfortunately, limit not equal to the function values here. So what the condition this one we violate is number 3, not satisfied. Right? Because the limit does not equal to the function value. So those are the 3 situations we have discontinuity situations here. Okay, so now let's take a look at how do I define the continuous from the right and the continue from the left. All right, so this is the same things here. So instead of only looking for the continue from the right, so basically I'm looking for, so if limit x approaching to a from what? From the right hand side. All right, because I'm only care about that for the f of x, right? So this limit exists, okay? Then my function value f of a exists. And then my function f value equal to the limit x approaching to a from the right hand side. Okay, so it's the f of x. So I know, okay, so here, be careful here. I know if the f of x is continuous at x equal to a, so obviously the f of x is going to be continuous from the right, right? Okay, so the same things here, if it is the continuous from the left. So what is continuous from the left? So it's very similar definition, would just be x approaching to a. Now I'm from the left-hand side, and then the f of x going to be, so this one is exist. Okay, so the same thing, f of the a exists. Then the same thing is the f of the a equal to the limit x approaching to a from the left-hand side f of x, right? So now I say this is, the from the left, so it's obvious. So then that means if it is continuous, then f of x also going to be continuous from the what? From the left. Okay, so that is we're going to take a look at some example, right? So when we talk about the continuous on the closed interval, all right, so what I mean the continuous on the closed interval. So if here you have a, b, all right, so here is your function. Because it's in the closed interval, I have the dot at the end, right? So the continuous in the closed interval, so that means f of x should be continuous every point on the open interval AB, right? So the inside this interval is going to be, continuous. Then for the A here, because I can only approach the A from the right-hand side, then we also need to know f of x will be continuous from the right at x equal to a, and then here I can only approach into b from the left-hand side here, right? So that's what I would say f of x is continuous from the left at x equal to b. Okay? All right, so now let's take a look at one more definition, then we can go to see our, some examples here, right? So what is the jump discontinuity here? Okay, so let's take a look at this last two, then we'll go to our worksheet and start to work on some problems here, okay? Okay, so the first type of the discontinuity we call this jump discontinuity. So what is jump discontinuity? So we said, f has, so the one, let me see here, the one side, so one side limit exists. But are different number. Okay, so basically, that means there is a gap. Okay, so what I mean the jump here. So like the example we just showed a while ago, let's take a look at up here. So in here for this situation, right? So for the second situation here, right? So we said the both left limit and the right limit exist, all right? But they are at the different value. So this situation, we know this we have is the jump discontinuity. So there's a gap in between here, all right? So in here, also, in here here this one's here, so this is a function value, and so this one's here is a different type of the the jump here, because there is an empty here and there's a gap in between here, right? So for this one's here, we can redefine this number. If we can redefine this number, then we will be continuous. So it will be, so for this situation, we call it is the removable here, all right? So let's take a look at what is the removable discontinuity here, okay? So okay, so let's write the formal definition about the removable discontinuity here, okay? So we said if f has a removable discontinuity, at x equal to b and at x equal to c. So what's that mean? So we say the limits at b and c exist. Okay, but f of the b does not exist, and while f of c exists, it is not limit x approaching to c and f of x. Okay, so the discontinuity are removable. Okay, if we can redefine is removable is because FB, so we can redefine FB and FC would make F continuous. Okay, so let's take a look at what we had before here, right? So in here, so this is the situation. So my limit, exists, but the function value is not exist. So now I can redefine the function value and then make it continuous. So this is removed. And so here, the function value is different in the limits, right? So I can redefine this also. So this is also removable, so discontinuity here. So like for this situation, so if I do have a situation like this, okay, so if I have a situation like this, so for this f of x is here, I cannot, if a here, right? So I cannot redefine this function because even I redefine this function, I still have a gap. All right, so that's why this will be a gap. Discontinuity is here. Okay, so now let's go ahead and take a look at some of our problems. Okay. Okay, so let's continue our worksheets and now let's take a look. We are in the problem 16 here. Okay, so for the problem 16 here, this is just to show you the graph and let's identify. So where is the discontinuity? So obviously this one, right, is discontinuous. We can visualize that. So this is -2. So what type of the discontinuity here? This is what we call is removable. Because if I redefined what is equal to f of x equal to -2, then I redefined this value and can make it continuous. So the next ones here is what is the -1. Why the -1 is discontinuous? Because when the x equal to the -1, so what is this one? This is the vertical asymptote. All right, so then the next one's here. So this one is then the x equal to, then the next one's here is x equal to 0, right? So x equal to 0. This is discontinuous. And what type of discontinuity is this one? This one is a jump, right? Because capital. Okay, so it's a gap here. Then the next ones here will be what? It's equal to 1. So x equal to 1 is here, right? So because there is a gap between, so this one also is a jump. Okay. So now let's take a look at this example. Basically, is try to tell us, the how to find the right limit and how to find the right continuous and the left continuous, right? So let's say what number, that does limit not exist, right? So limit not exist, we learned a lot limit problem. So the first is will be x equal to 1, correct? So x equal to 1, the limit not exist. Why? Is because if you're approaching from the left, you are approaching to this value. If you are approaching from the left, right, go down here, you will get this number. So their limit not equal, right? So I know the limit x to a to 1 is not exist. How about this one, 1, 2, 3? So limit x approaching to 3, this one limit exists because you're approaching from the left hand side, and you're approaching from the right hand side. They will approach to this same value here. So the 3 is okay, limit exists. So the limit only not exists is equal to 1. Okay, so now the next thing they ask us is what number f of x is not continuous? All right, so obviously, if limit not exists, it's obviously it's not continuous. So x equal to 1. X equal to 1 is not continuous, and x equal to 3 is not continuous, right? And so the next one they ask us here is what number a does x approach a exist, not continuous? So like we talk about x equal to 3, right? Because when they both approaching to the left, right, then what do? They all approach to these values, right? So that's why we said it's a continuous, but not, it's limit exists, but not continuous. All right, let's take a look at this one's here. So what number a limit does not exist? Okay, so the first one is here. We know is x equal to 1 here, right? So x equal to 1. So this limit not exist is because of what? This is because of they are approaching to the asymptotes, right? So this is because the x, so they are approaching to the infinity. Then the next one, the limit is not exist, is here, is the jump point, right? Because when you're approaching from the left, you're approaching to here, and when you're approaching from the right, you're approaching to here. So this limit not exist. So this is 1, 2, 3, 4, 5. So this is 5. So it's x equal to 5. Okay, so now the next questions they ask you is which function, which is not continuous. By looking at the graph, obviously x equal to 1 is not continuous. So this is 1, 2, 3, 5. So 3 is not continuous, and the 5 is not continuous. So let's see, let's say what number A limit exists but not continuous. This is 1, right? So because when we both come from the left, from the right, they both going to approaching to this limit, right? But then the function value is different. So when the x equal to 3, limit exists, but it's not continuous because limit does not equal to the function value. Okay, now let's take a look the next question. The next question, they say, given the functions, f is discontinuous here. All right, so when we take a look at this type of the function, we know, the function here, the x squared, x1 over x, all those are this is a polynomial, and this is 1 over x is rational, but the denominator is not equal to 0. So we want to see which one is discontinuous. So let's take a look. So the only possible situation will be on this jump point, right? So it's -1 and 1 here, because this is a piecewise function. So what I need to do here, follow my, the continuity definition. So it's a limit x approaching to -1 from the left-hand side. If it's from the left-hand side, see here, that means it's lessening, right? So I need to lessen, so I need to use the x squares here. So that means x squared. So from the -1, so this is -1 to the square is equal to 1. And then I need to do the limit x from the right-hand side, -1 from the right-hand side. So if it's from the right-hand side, that means it's greater than. So it's here, correct? All right, so I have an x here. So this is give me -1. So obviously, unfortunately, this is not equal. So limit is not equal, right? So we know the limit is the first condition, the continuity need to satisfy. Limit is not equal. So I know x is discontinuous at -1. All right, now let's take a look. Limit x approaching to 1 from the left-hand side. The 1 from the left-hand side, so it's less than 1, so still is x. So this is what? This is 1. And then the limit x from the right-hand side, right? So right-hand side, that means what? It's a little bit greater than 1, right? So we'll be here, okay? So what I do here is 1 over x. So this is 1. This is good. So this is equal, right? So 1 equal to equal. So limit exists, all right? So limit exists. Then let's take a look the function value. So f of 1. So the equal sign happens here. So it's 1 over 1. So it's 1. So all these three are equal. So I know x equal to 1 is continuous. So the only discontinuous will be at -1. Okay, so now let's see here, right? So let's say the second part here, let's say f is only continuous from the right. Okay, from the right. Okay, so now let's, I think it will be easier if do a picture here. So this is -1, this is 1. Okay, so from the right here, that means if I approaching to 1 from the right, if I approaching to 1 from the right, this number is 1. 1 is equal to 1, right? So 1 is equal to 1. So from right is okay. But since, this is at the 1 is continuous, that means I'm going to be a continuous from the right and continuous from the left. And this problem they ask us is only, all right? So 1 will not be our choice. How about -1? Okay, so the -1, if I approaching from the right, okay? So approaching from the right is this numbers here, right? It's this numbers here. Then the function value is from the right, right? So from the right, what are equal to the function values here? The f of what? The -1. F of -1 is where? Is here. It's -1. Good. They are equal. All right. So that means so this one's here. Okay, so only from the right, right? So this one will be x equal to -1 here. Because when I do from the left, it's not. So it's only continuous from the left, right? So what here do not exist, right? So only, that's why. Okay, so 1 is continuous from the right and continuous from the left. -1 is only continuous to the right. So I don't have any point, only continuous to the left. All right, so in order not to let this video become too long, we will stop here, then we'll go to the next video to continue, do a few more questions here. All right, and nice talk to you, and hope to talk to you on, hope to talk to you in our next video. Okay, bye. Have a good day. Okay, bye bye.